Welcome to the Climate Layer. I'm Alex. I hope wherever you are listening today, the air's clean and the sky's clear. It sounds like a simple wish, but by the end of this episode, you might think about it a little differently. Today, we're doing something a little different. We are zooming out, way out. Over the past 4 episodes, we've talked about why climate communication is broken, how oil shaped the way we move, how the grid is changing, and last time, how misinformation has slowed our response to all of it. But today I want to challenge something that even the most climate-aware people among us tend to assume, that climate change is the environmental crisis, that if we solve carbon, we solve the problem. We don't, and today I want to show you why. So in 2009, a Swedish scientist named Johan Rockström led a team of researchers who asked a deceptively simple question. What are the conditions that have allowed human civilization to thrive for the last 10,000 years, and how close are we to pushing beyond them? What they came up with is one of the most important frameworks in modern environmental science. They called it the planetary boundaries. 9 systems that regulate the stability of Earth. 9 dials that need to stay within a certain range for the planet to remain in what scientists call a safe operating space for humanity. Here's the part that should stop us all in our tracks. We've already pushed 6 of those 9 boundaries beyond their safe limits, and number 7 has just happened. Not someday, not if we are not careful, already. And most of us have only ever heard of one of them. So let's change that. Think of the Earth as a living system with built-in limits. Not arbitrary limits, but the conditions under which life as we know it evolved and flourished. For roughly 10,000 years, through what scientists call the Holocene epoch, those conditions were remarkably stable. Temperatures, rainfall, ocean, chemistry, biodiversity, the composition of the atmosphere, all of it held within a relatively narrow range. And within that range, human civilization built everything we have. Rockström and his colleagues identified 9 planetary systems that define those limits. Climate change is one of them, and it is the one we talk about the most. But the others are biosphere integrity, which is essentially biodiversity, land system change, which covers deforestation and how we use the planet's surface, freshwater change, which is about the disruption of the global water cycle, biochemical flows, which tracks the disruption of nitrogen and phosphorus cycles through industrial agriculture, ocean acidification, atmospheric aerosol loading, which is essentially air pollution at a planetary scale, stratospheric ozone depletion, which most people know from the story of the ozone hole, and novel entities, which covers synthetic chemicals, plastics, and microplastics that have never existed in nature before. 9 systems, 9 boundaries, and as of the most recent science, the Planetary Health Check published in 2025, 7 of them are already crossed. Climate change, biosphere integrity, land system change, freshwater change, biochemical flows, novel entities, and now ocean acidification. All 7 show worsening trends. The remaining 2, ozone depletion and atmospheric aerosol loading, are actually the most hopeful part of the story because they show what is possible when we, as a collective society, act. The ozone layer is healing. Aerosol pollution is dropping, not because the problem solved itself, but because the world made a decision to fix it. That is worth remembering. What makes this framework so powerful and so unsettling is not just the number of boundaries we've crossed. It is the fact that these systems do not operate in isolation. They are deeply, fundamentally interconnected, and that is what we are going to spend this episode unpacking. Climate change gets headlines. It drives the politics, the protests, the policy debates, and it should. It is genuinely urgent. But some of the other boundaries we have already crossed are receiving almost no attention at the scale they deserve. Let me walk you through a few of them. Start with biosphere integrity, what most of us would call biodiversity loss. Scientists believe we are currently living through the 6th mass extinction event in Earth's history. The previous 5 were caused by catastrophic natural events, asteroid impacts, volcanic eruption, ice ages. This one is caused by us. Species are disappearing somewhere between 100 and 1,000 times faster than the natural background rate. And the consequences go far beyond losing animals we love. Biodiversity is the foundation of ecosystem services, the process that pollinate our crops, filter our water, regulate disease, and absorb carbon from the atmosphere. When biodiversity collapses, those services collapse with it. This boundary is already crossed, and we barely talk about it. Then there are novel entities, a term that covers synthetic chemicals, industrial pollutants, plastics, and microplastics, human-made stuff. This boundary was only formally assessed in recent years, and when researchers looked at where we stood, they found we had already crossed it. We have introduced thousands of synthetic substances into the biosphere that have never existed in nature before, and we do not fully understand the long-term consequences of most of them. Microplastics are now found in human blood, breast milk, and placentas. They have been discovered at the bottom of the Mariana Trench and in the ice of Antarctica. We are not just polluting the environment, we are changing it at a chemical level in ways we are only beginning to understand. And almost nobody is talking about this at the scale it deserves. Then there's ocean acidification. The ocean absorbs roughly 25 to 30% of the CO2 we emit every year, and together with land ecosystems, absorbs close to half of our total emissions. It has been acting as a massive buffer, quietly slowing the pace of atmospheric warming in ways most of us never think about. But that absorption comes at a cost. When CO2 dissolves in seawater, it forms carbonic acid, making the ocean more acidic. Since the Industrial Revolution, ocean acidity has increased by roughly 40%. That might sound abstract until you understand what it means for the living systems that depend on stable ocean chemistry. Coral reefs, oysters, mussels, and the tiny sea creatures that form the base of entire marine food chains build their shells and skeletons from calcium carbonate. And calcium carbonate dissolves in acidic water. We are literally dissolving the foundation of marine ecosystems, and we will go much deeper on this in our next episode. So this is part of the episode I most want you to sit with, because here's the thing about the planetary boundaries. They're not 9 separate problems that we can solve one at a time. They are 9 interconnected systems that affect each other in ways that are sometimes subtle, sometimes dramatic, and sometimes irreversible. Scientists have a term for what happens when crossing one boundary destabilizes others. They call it a tipping cascade. And it is exactly what it sounds like. One system tips, which stresses another, which tips, which stresses another. And the chain reaction becomes harder to stop with every link. Let me give you a concrete example. Warming increases ocean temperatures. Warmer oceans absorb more CO2, which increases acidification. Acidification damages coral reefs. Coral collapses, destroys the marine biodiversity that depend on those reefs. And biodiversity loss weakens the ocean's ability to absorb carbon, which accelerates warming, which makes it all the worse. That is not a hypothetical future scenario. Parts of that cascade are already underway. Here's another one. Deforestation, which falls under land system change, releases the carbon stored in trees and soil, which accelerates warming. Warming drives drought and wildfire, which destroys more forests, which further reduces biodiversity, which weakens the carbon absorption that forests provide, which accelerates warming further. Each step in the cascade makes the next step harder to stop. And this brings me to something I think is one of the most important ideas in this entire conversation. We have spent decades framing the climate crisis as a carbon problem, and carbon matters enormously. But if we only focus on emissions, we miss the bigger picture. Because even if we hit net zero tomorrow, biodiversity loss would continue, chemical pollution would continue, fresh water disruption would continue. And without those systems functioning, the planet's ability to regulate itself, including its ability to manage carbon, would keep declining. What this tells us is that we cannot just decarbonize our way out of this. We need to actively restore and regenerate the systems we've damaged. Forests, soils, oceans, biodiversity. These are not separate environmental causes competing for attention. They're one interconnected living system that either heals together or continues to decline together. That is what regenerative thinking means, not just reducing harm, but actively rebuilding capacity. And the good news, and there's genuinely good news here, is that many regenerative solutions address multiple boundaries at once. Restoring a forest sequesters carbon and rebuilds biodiversity and stabilizes local water cycles. Protecting ocean ecosystems reduces acidification and supports fisheries and maintains the carbon sink we depend on. The connections that make tipping cascades dangerous also make regenerative solutions powerful. So this might be the most well-intentioned myth we have ever tackled on this show. It comes from a genuinely good place, from people who care deeply about the planet and have rightly identified climate as a critical priority. But it contains a fundamental misunderstanding of how Earth's systems actually work. The idea is simple and intuitive. Cut emissions, stop warming, and nature recovers. And there is some truth in it. Reducing warming absolutely helps other systems, but is not the whole story, not even close. Biodiversity loss does not stop when emissions do. Species lost to habitat destruction, overhunting, and chemical pollution are gone regardless of what happens to the atmosphere. Novel entities, the plastics and synthetic chemicals already circulating through every ecosystem on the planet, do not disappear because we build more solar panels. The nitrogen and phosphorus we have flooded into waterways through industrial agriculture will continue disrupting freshwater systems and creating ocean dead zones whether or not we hit net zero. Each of these boundaries has its own drivers, its own feedback loops, and its own timeline. Climate action is the floor. It is necessary. It is urgent, but it is not the ceiling of what we need to do. And here's the deeper insight. If we solve climate but allow biodiversity to collapse, we lose the ecosystem that regulate our climate. If we solve climate but ignore chemical pollution, we undermine the biological systems that make Earth habitable. The boundaries are connected, which means the solutions need to be connected too. Climate is not the only layer. It is one of 9, and we have work to do on all of them. So that is the Planetary Boundaries Framework. 9 systems that keep Earth stable. 7 already crossed, and all of them connected in ways that make isolated solutions insufficient and regenerative thinking essential. I want to acknowledge something. This was a technical episode, more so than usual, and I know that sitting with the scale of what we covered today can feel heavy. 7 boundaries already crossed, tipping cascades already underway, systems we depend on already under stress. But here is why I think it matters for this show specifically. The climate layer exists to cut through misinformation and make sustainability make sense. And to do that well, we have to remind ourselves what we were actually fighting for. Not just lower emissions on a spreadsheet, not just a policy target or a net zero date. We are fighting for stable oceans, for living soils, for clean air and fresh water, and a planet rich enough in biodiversity to keep regulating itself. That is what is at stake. And keeping that full picture in mind is what separates genuine climate communication from just talking about carbon. The scale is enormous. I will not pretend otherwise, but the solutions are real. The behavioral shifts are possible, and here's what gives me genuine hope. The more of us who understand what we're protecting, the more our individual and collective choices start to add up. Not in a guilt-driven personal responsibility way, but in a systems way, where enough people shifting in the same direction actually moves the needle. And remember how I opened today, hoping the air was clean wherever you were listening from. That wish is connected to every boundary we talked about today. Clean air, stable climate, living oceans, thriving biodiversity, fresh water, a planet free from chemical pollution. These are not separate wishes. They are one wish for a world that works. Next time, we're going to go deep on one of the most critical boundaries of all, the one that covers 71% of our planet, generates half the oxygen we breathe, absorbs a third of our carbon emissions, and is changing faster than almost anything else we have discussed. Next time, we're going to the ocean. Until then, stay curious, stay grounded, and keep